Hello and welcome to week 4 of Alliance Gator Design Studios training. And this week we have the most exciting topic of all. When we allocated whose week was going to be in what studio, and we had G2, we had Sealers, we had Nitro, we had Extreme Edge.
Gator base, some exciting topics.
And then when I saw that I was on the list for geotextiles and fabrics, I was as giddy as a schoolgirl because there's just nothing more exciting than Gator base, than Gator fabrics and geotextiles.
Yeah, I mean, fabrics really aren't that exciting.
They're not.
They get buried in the ground and they disappear. Nobody ever thinks of them again. But we're going to do our best to make it exciting today, right, Topher?
We're going to do it. We're going to do our best. We've got some fun demos. We got some really neat videos. Open up the questions. Mike's going to talk about the platform. It's a demo platform. So how do they work this, Mike?
All right, so if you go up where that arrow is pointing, that'll take you to full screen mode, give you the best experience to see all the magic that we have for you with Gator fabrics and grids. If you open up the chat window where the circle is flashing and pointing to, that arrow is pointing to the line, you can ask any questions. We love questions. Helps keep us on our toes, keep it interactive. If we don't get back to you live here, we'll make sure that our little elves behind the scene get you an answer.
And the questions really do kind of help us keep the flow. It kind of helps us know where we need to focus on. It gives us some things to talk about and keeps it a little bit less dry and a little bit less rehearsed.
All right, so before we get into the actual meat of this presentation here, why don't we touch on the prizes that we're giving away this year?
Absolutely. We've got some fantastic prizes. We've got a Yeti hopper that we're giving away. We've got some Amazon gift cards. We've got some really cool Alliance tumblers. And those of you who are aware, who have never been part of the Insomnia Cookie Crunch, they are amazing cookies nationwide. All these prizes will be sent directly to you. And I think we have a list of our week 3 winners that we can go ahead and throw up there. And we'll throw a couple mentions out to you.
So who won last week?
Who did win last week?
Let's see. All right, we've got, looks like Michael from Hudson Quarry in New Hampshire was the winner of that big Yeti backpack
That's
cooler.
absolutely fantastic. And Chris got one of the Yeti tumblers out of Rock and Wood out of Michigan.
Yeah, and it looks like our friends down in Georgia at Willow Creek Products and Aquatic Innovators in Wisconsin cleaned up with those Insomnia cookies.
That's fantastic. And a bunch of other guys won some stuff as well. Enter to win. Those prizes will be mailed directly to you. So enter to win at the end of this at the end of this presentation. There'll be a couple web pages to go ahead and get to you.
Yep. All right. So I guess we can move on and actually talk about Gator Geotextiles and Gator Geo Grids, right?
Yep.
We built out this whole studio to make sure that we could bring great educational programming to you. It's fantastic. You know, we can do demonstrations. We can do all kinds of cool things. We've got our studio dog sitting here live, so you'll see her make an appearance throughout the show.
Multiple times.
Multiple times.
So tell me what we've got here. What's this contraption we got built up here, Mike?
All right. Well, we've got a little demo box that we built out here. We wanted to show people kind of a real-life cross-section of how this would work.
Okay.
So let's take a look at the demo box real quick.
What do we got?
All right. Well, what do you do when you start a hardscape project? You dig a hole, right?
Yep.
And you got dirt at the bottom of your hole. So you compact that dirt, and then you really should add in a geotextile fabric to separate your native soils from your aggregate base.
And if I don't do that, what's the net? So if I find this don't have to be important, what's going to happen? What's the consequence?
Well, then you get fired. All right. So anyhow, we need to have that separation. Aggregate base serves a useful purpose, right? It supports our project. But if that aggregate base, whether it's crushed stone, crushed concrete, clean 3/4 stone, if that starts to migrate into the native soils, into the clay, into the sand, you lose the integrity of that foundation. So what might have functioned as 6 inches of crushed stone base as a foundation might start working like 4 inches of base or 3 inches of base.
And it's going to start pumping through.
So you'll start seeing the sand migrate, you'll see it pump through, you'll see some settlement, you'll see ruts develop if it's a driveway. So that fabric can really work wonders for your hardscape project.
Gotcha. Very cool.
That particular fabric's our GF 4.4. And that's going to provide separation, like we just talked about. It's going to allow great drainage, so water can work its way through it, and we'll touch on why that's important later. And it also provides reinforcement, so it's going to actually reinforce our structure here and help prevent any kind of issues with, you know, differential settlement and that migration of materials that causes settlement as well.
Fantastic.
So it's really a great product, and it's really going to be the go-to product for any residential hardscape project, you know, that our contractors typically build.
Gotcha. All right. What else we got going on here?
Well, I think that we need to show people how that actually works and why it works.
Okay.
Right? So we've got this little pan of dirt. So let's throw that up here. So if you have your native soil here,
Yep.
and we drop a block on it, you know, what's going to happen? It's going to sink in. If we use fabric,
Right.
it'll help to minimize that impact force, that single point load.
Well,
so
show me how it's going to do with fabric.
let's throw some fabric over top of here and simulate it kind of being stretched tightly like you'd see on a hardscape project with all that soil. All right. Penelope wants to check it out.
There you go. What you got there, pup?
All right, so let's, Penelope, go see Lou. Go see Lou. All right.
Just to reinforce that this is live, that was not displayed right there.
All right, so let's zoom in tight here, and you can see that we have a very little impact divot. You know, there's really not much there. That fabric helped to take the force of that point load and spread it out over a slightly larger area and minimize that impact force.
So what if I didn't have that fabric down there? What if I was just trying to cheat my way out and just want to go ahead and skip the
Well,
fabric
let's see
step?
what happens. So let's drop that again. All right. So you can see we got a little bit bigger impact crater. So it sunk in a little bit more, a little bit deeper. You're going to have less integrity of your projects without using fabric.
So having that fabric just really helped just displace the weight and distribute it over a larger surface area.
Yep, exactly.
Gotcha.
You know, you're always going to have areas where the soil's not perfect,
Right.
where you might see some substandard areas, and over time, you know, those settle.
Okay.
Maybe it was a tree stump that was there 50 years ago.
Very cool.
Having fabric underneath your project can help bridge those areas of differential settlement,
Yep.
minimize that effect where you always see one paver dipping in a patio, or that little 2 or 3 pavers where the corners are dropping together.
So we always kind of joke amongst Alliance and with dealers that the use of fabrics is not all that common, and it seems to be an extra step that a lot of people just don't take into consideration as far as what fabrics to use and why to use them.
It's really crazy. It's such a inexpensive insurance policy. It makes your
Yep.
job so much stronger, and it'll make them perform so much better for very little expense and really very little effort in terms of installing them.
Yeah. So if you guys have any questions, please go ahead and use that chat box. Go ahead and type in your questions. We have some moderators back there. I don't know if we've had any questions come in since, but as they come through, we'll try and answer them for you as we get to them in case we kind of go over things too quickly or we don't describe something clear enough. So go ahead and use that chat box.
So we showed you a little bit about how this reinforcement here works. You know, now we're going to show you a little bit about how you install it, because
Okay.
if you don't install it correctly, it's not going to perform its intended function either.
Gotcha. All right.
All right. So let's bring that table in over here, Kirk. Kirk is actually our Michigan rep. He is joining us to help out. So we will stretch our fabric out. So you always have your fabric stretched out, nice and tight on the ground. We've just put our aggregate base on top of the fabric. Now let's imagine that a hole develops underneath our fabric. Fabric held up that stone, right? As that stone, as the paver surface wants to push down, the fabric's providing a force upward, equal and opposite in the other direction. So that's that reinforcement category. So now let's assume that we have a wrinkle in our fabric.
Sloppy
or a fold,
install.
A sloppy install. Maybe people were, go ahead, pour that on. Maybe someone was installing all of their aggregate using a skid steer, and they just drove that skid steer right over top.
Right. Lots of sag, lots of displacement.
Yep.
That's going to be a mess.
So any wrinkles, any folds, any issues like that you have in your project are going to result in that project kind of sinking.
Gotcha. Very
So
cool.
sinking's no good, right?
No,
we don't
bad.
want any sinking. We don't want any settlement. Let's pull this off here, Topher.
All right.
Drop back down. Other thing we need to keep in mind is just how we go about. Where do we start laying the fabric? Let's assume that we had a slope here, right?
Okay.
I'm going to come in and I'm going to put my fabric in. And I'm going to do it just like this. I'll start up by the house at the top of the driveway and work my way down. Does that sound good, Topher?
It doesn't. I've worked as a roofer before, and this is a disaster waiting to happen because you're going to have water go ahead and get trapped underneath. It's going to migrate into your subsoils, defeating the purpose.
You know, we have bedding sand underneath here. You know, that water working its way under each successive piece is just going to continue to wash out material and cause a problem.
So how do we want to install
We're
it?
going to go the other way. We're always going to work from the bottom of our slope and work our way up. Shingle that, just like roof shingles. That way our water cascades over each successive piece and not underneath.
It's going to sheet right out.
Now, on a residential project, you typically overlap about 6 inches.
Okay.
If you're doing a pedestrian project.
Right.
If you have a driveway, you're going to want to overlap about 12 inches.
Okay.
And always wrap up the sides of your project, obviously. Make sure you're wrapping up the sides of your excavation, up against curbs, up against the foundation of a house, anywhere that the aggregate, the soils, the sand setting bed could potentially start to migrate.
Gotcha. Very cool.
Yeah, it is pretty neat.
All right.
All right.
It looks like we've got a question up here, and I can't read what that question is. GB, can you go ahead and tell me what that question is?
How important is it to, hey, I think you need to go to the eye doctor there, Topher.
I know I need to go to
How
the eye
important
doctor.
is it to tension the fabric in the field like you did in the demo? So you don't have to actually pre-tension the fabric, but what's going to happen naturally is that you have that fabric stretched out over the ground, over your excavation, and then you cover it with stone, whether it's crushed stone, clean 3/4, and all of that weight provides that force that Topher and I were providing to the fabric. So basically you want to make sure you don't have any wrinkles, and then the weight of all the stone and the pavers that you put on top of it is going to provide the rest. All that
So I don't have
tension
to
that
go ahead and pull that out and then pin it all along the outside edge and go ahead and get it squared away.
No, just
Gotcha.
make sure it's flat, and make sure that if you're doing your stone installation with a machine, you're working your way in.
Okay.
You don't drive all the way in first and crinkle and wrinkle all that fabric. So great question, and it's best to have that lay as flat and seamless as possible. Any wrinkles or folds are going to negatively impact the performance there.
Very cool. Very cool. What else have we got going on over here?
Well, hey, that was a quick run through of fabrics and why we use them. That separation, reinforcement, and drainage characteristic. We're going to transition over to grid here and talk about grid a little bit. So Alliance Gator grids, they're all biaxial and they all have no memory. So those are two features that a lot of our competitors don't have.
All right, so biaxial is going to mean what? And why wouldn't a fabric have memory? What is,
all right, so
special?
biaxial means that it has strength in both directions, right? So we have strength in the lengthwise version of the roll, and we have strength in the shorter crosswise direction of the roll.
Okay.
And that's very important because that's going to give us the ability to install it parallel or perpendicular to a project and greatly speed up our efficiency.
Gotcha. Understood.
And how about that no memory idea, right?
So why is that such a big deal? Why is that such a big deal that we get something with no memory?
Well, no memory is fantastic because that means that your roll is not going to be springing back up in your face. So I've got a roll here. We're going to drop it down, and here, try to unroll this with me. All right, so
All right, that's aggravating.
let's try it again. I think we can do better this time, right?
I'm going
all
to
right.
pin it down.
Pin it down a little bit and unroll it.
Yeah.
All right.
I'm going to go down here and pin it.
Hey, it's following us.
Yeah.
That's a little bit disturbing.
So this is why when we came out with our no memory fabric, it was a big deal. It's a big deal to come to be a part of. Granted, there's nothing sexy about geogrids, but something that where you can roll out and then not have it follow you down your project.
Hey, that's pretty nice.
It does. It makes, especially if you're a small man crew, something like this is going to save just a little bit of extra time, save a whole lot of excavation and a whole lot of aggravation.
Right, so while I'm rolling it out, I'm not worried about trying to throw a shovel full of dirt or stone on top of it to keep it in place.
Yep.
Because of that biaxial nature, it has the same strength whether Topher and I pull on it this way or we pull on it this way. So that's fantastic, right? You don't have to worry about which direction you're rolling it. You don't have to cut lots of little pieces to keep running it perpendicular to your wall. Depending on what your wall calls for, you can roll this out parallel to your wall and really install fast.
All right, so here's a question that does come up. When I am rolling this out, if I have to have several pieces come up, am I butting it over or am I overlapping so I have really good coverage? Because I got to assume that if one piece is good, two pieces is going to have to be better.
Hey, that's a common thought in the industry, but you never want to overlap grid. You know, you're always going to overlap fabric, 6 inches on a pedestrian project, 12 inches on a driveway, but grid never gets overlapped. Why is that? Because if you put layers and layers of grid over top of each other, this is kind of slippery stuff, right?
Yep.
So we want a friction hold in the soil. We want dirt and stone working its way through all these squares, which are called apertures. So if we have an issue where this is actually overlapped, you could get some kind of a slip, a slide, lack of friction hold, and actually cause a little shear point and a failure plane.
So if I need to butt two pieces up together, I'm better off having somewhat of a gap than having any type of overlap whatsoever.
Yes. In fact, if you're doing a curved wall or something, you know, an outside radius or something of that nature, you might have big triangular gaps in your grid, which you'll simply overlap on your next layer, 6 inches or 12 inches higher.
So let me just be sure I can picture that. I've got a layer of geogrid, then I've got stone, then I've got another layer of geogrid, and that's where my overlap is occurring.
Correct.
Gotcha. Okay.
So you do kind of sandwich it and overlap, but never directly on top of it.
Gotcha. Makes sense.
So let's roll this stuff back up, since it didn't roll up all by itself on us. All right, so that's one of the great benefits of the Alliance, actually 2 of the great benefits of the Alliance grid. Now, I think we should really figure out a nice demonstration to show all these people how grid actually works.
Why does it work?
Right?
What do we got here? Why do I have this box?
Why do you have that box?
What's in the box?
We're going to move it back real quick here because we got to do 2 demonstrations.
Okay.
That box has nothing in it, but we're going to fill it with stone. And then you're going to stand on it. We're going to see if you make it collapse.
Okay, let's see. How much stone you want?
Well, let's put this bucket in, do a little compaction. We'll compact our stone. All right, give me another bucket. All right, and we'll compact this. So that's about, I don't know, 10, 12 inches high, clean 3/4 stone, compacted well. Put that top on it there, and go ahead and climb up.
All right.
Here, you want to use that?
I'm going to use this. This is going to be OSHA approved.
All right, so then I am going to pull the sides away. You ready?
Okay, I'm ready, but where's I'm going to get?
All right. All right, so you can see that collapsed. It did not hold Topher up. And
I've been working on weight since the holidays, so that's not entirely my fault.
It's not your fault at all, actually. We're going to show you why grid is so important. Grid can actually reinforce that structure so that it can support Topher's weight and even weigh more than Topher's weight.
Let's not get carried away.
All right, so we're going to layer our grid inside here this time. And this is a pretty small demonstration, so we're going to... let's get this whole bucket in. We'll do them kind of similar to how we did the last one.
All right.
So we're obviously exaggerating the placement of grid a little bit for the sake of this demonstration.
And my safety.
And Topher's safety. All right, give that a little compaction. All right, and we'll keep pouring. All right. Go ahead.
Now, Mike, in a typical installation, I know this is a demo. We're kind of working through this. How many inches of each lift should I be putting in there?
Well, there's really no set rule of thumb. Okay. That is going to depend on your design. So your design may say you need grid every 3rd course. It may say every course. It may say every 6th course. So it really depends on your actual plans.
All right. So before I climb up on this thing and see the final result, have we got any questions? Any questions that have come across here?
We sure do. So, Mike, they're asking, is it still flexible when it's cold?
Gator grid is very flexible when it's cold. So colder temperatures really don't matter. It's a PVC coated product, and it really has great flexibility. So I wouldn't worry about cold weather installs other than your fingers and toes getting a little chilly.
I gotcha. I can read this one because I'm closer. Is there an upside or a downside? I'm assuming they're still referring to the grid. Is there an up or down?
Well, since it's biaxial, there's no front,
there's
left,
no left,
center,
there's
bottom,
no right.
top, or bottom. You can install it however you want.
Yep. Kind of takes the guesswork out of it.
All right. Anything else?
What widths does the GeoGrid come in?
GeoGrid. Well, we are selling our GeoGrid in 6-foot and 12-foot rolls for the 50/50, which is probably the most common product. You know, if you go down to the 30/30 or 20/20, we do have it in 4-foot rolls.
Okay.
That's more of your small garden walls. You know, anything bigger, you're probably looking at that 50/50 where you get those 6-foot and 12-foot rolls. Raised patios, staircases, you know, you got that 4-foot roll option.
Guys, there's a lot of information coming out there. Please, you don't have to be taking notes here. Obviously, you're all going to get a recording of this afterwards. But the short version is if you have this question that comes up, or if you have questions about, hey, what size did it come in, when do I use it, how do I use it, please reach out to your Alliance rep.
Right.
So are we ready for the big reveal here?
Yeah, I think we should do that, right?
Okay.
Hop on there.
Let's see what happens.
So while Topher stands up there and I pull away this box, we'll see. Does he stay or does he fall?
Let's see.
All right.
All right, so obviously some of it did leave off the sides, but I'm still at the same height I was. So that geogrid obviously kept the condensation of that aggregate together to be able to sustain my not quite insignificant weight.
And that's the whole point, right? Not Topher's insignificant weight there, but the idea of the prevention of lateral movement. We don't want that stone to spread out like the previous pile. We want that stone to be restrained from moving and support that column, support that retaining wall. If you don't have that column, you're going to have problems.
Right.
So I touched on briefly the different sizes, but I probably should have talked about the different strengths, right? So we have a Gator grid 50-50, a 30-30, and a 20-20. Those are metric designations, corresponds to the pound force of each one, but to put it very simply, 20-20 is your garden wall, very small retaining wall, just cheap insurance kind of product, small staircases. 30-30 is a stronger grid, and that 50-50 is really what you're going to use for any substantial walls or any substantial, earthwork operations.
Very cool.
All right, so what
Now
happens
what?
if you don't use grid? You want to throw that picture up there, Ryan?
Let's see.
All right, so that's obviously pretty dramatic, larger scale than most of the projects that we're talking about, but it does illustrate a point. Hopefully no one that's on this webinar is ever on the news for a project like this. That happened in New York City. It was big news not all that long ago. A retaining wall that stood for hundreds of years just collapsed, whether it was excessive moisture surcharge or just random chance. But
That's absolutely terrifying. I don't know if you're the owner, the contractor, to know that you were responsible for something like that. That's utterly terrifying. So
right, and it's tough to build a wall that's going to hold back everything behind it.
Yeah.
You've got tons and tons of soil. When it rains, you add tons and tons of weight to it. So if you don't reinforce the soil, the stone behind your wall, it's only a matter of time before you have a failure of the face of that wall and everything behind it goes with it.
And obviously what we're demoing here is very different from what you just saw in that picture there. A wall that magnitude, you're going to want to get that engineered. You're going to want to have a stamp on that. That's not exactly the same scale of what we're working with here.
Right, and those engineered plans are going to tell you what strength of grid you need, how often you need to put it in different layers, how far back you need to go, and really dial in all those things that you were thinking about. So I think we have a few questions.
All right, what have we got on there for questions?
You cut small sections of the grid. Does that still function the same as large squares? Would grid function if cut into a triangle or some shape different than a square? Well, we're cutting small squares because we have a really small project here. Typically, you would want pieces that were corresponding to your project size.
Right.
And that engineer is going to be the one that really tells you how that works and how it's going to be designed, how it's going to be installed. You wouldn't want to cut 1x1 squares. It still works, but it's not going to be as strong as a 4-foot long strip or a 6-foot long strip.
It's still going to add structural integrity, but the size of it's going to be depending upon the size and scope of what your project is.
Correct. I mean, some huge walls, you're going back 20 or 30 feet to stabilize the soil behind it.
Okay.
And we're just showing a couple of small scale demos.
Very cool.
Anything else?
What happens when you put the grid every 6 inches of stone? They're talking about the lifts.
Oh, it's really strong. Typically, you wouldn't have grid every 6 inches. That would be overkill for most scenarios. You'd be talking about every 3rd course of wall block, every 4th or 5th course of wall block.
I think in that demo they were doing it maybe every 2 inches for a dramatic effect.
Exactly. Exaggerated because of the scale. We don't have a lot of area to prevent that lateral movement. Obviously, some stone fell out the sides. That's to be expected. So over dramatic for our purposes. But we're going to zip down to our demo box again and kind of walk you through a little bit about how you'd use grid in more of a real world situation rather than that demo box.
Okay.
All right, so the first thing we'll talk about is reinforcing base. Hey, we just talked about walls. People generally think about grid and walls together, right?
Only as a wall product, yeah.
Maybe raised patios or stairs, but you can also use GeoGrid to reinforce your aggregate base, and it works really well.
How is that going to help me?
All right, well, the whole point is that this grid has squares in it, right?
Also known as?
Also known as apertures.
Not apparitions?
Not apparitions.
Okay, fair enough.
Although we may see some of those later, right? So if you have these apertures and you get stone in the apertures, those nylon strands actually prevent the stone from spreading sideways. So you're not getting that movement of the stone going laterally. And that's what held you up in that box. That's what's going to make our foundation, our base, much, much stronger.
Okay.
And it works well with crushed stone or clean stone.
Right.
Now, where's that piece? Where's that little extra piece? I think you're
extra
stepping on it.
I think, there it is.
Right, so we talked about how you would use it, right? You're not going to ever overlap.
Don't ever overlap it, okay? Because
that-
that's making this aperture even smaller, decreasing the amount of resistance that's going to go ahead and create it.
And you've got the potential for it to just slide,
go ahead and
right?
fix- yep.
It's going to slide very easily on another piece of grid. So we want to make sure there's always they're butted up. There's a little bit of separation. If you did happen to have, let's see how this shows up. Yeah, if you had a wall that was curving, right? This triangular piece with no grid is not a problem. You have to make some, sacrifices to follow that wall as you move around.
Right.
You can't do it perfectly. So,
Or as you're saying, I could go ahead and lay another layer of stone on top of here, and then have another section on top of that.
what you would really do is everything would go like this, right? You'd have your little pie wedges as that wall curved.
Okay.
Then you'd come in and you would do 2 more courses of wall block. And the next time you put your grid
Gotcha.
in, you would make sure that it actually covered that little pie cut wedge and reinforced that area.
Got it. That makes sense.
So it'd kind of be like a staggered, multi-layered kind of thing.
Got it.
All right, so we've reinforced our base, made that much stronger, and we're going to work our way up to our raised patio area. So we've got clean chip on top of our 3/4, our paving stones, and we've made it to our raised patio here. So raised patio, we got our wall block, we have our clean 3/4 inch stone filling it in, and we're going to reinforce it with some grid.
Now, do I have to lock this grid in with any type of pin and lock system or glue? Should I be gluing this down?
No, there's no need to glue it in. If you did have some kind of a pin and lock system, those pins would go right through the apertures.
Right.
If you had some kind of a tongue and groove, a batter system, this grid is flexible enough, it's going to fold right into those.
Now, how far to the front should I bring this as far as the face of my wall?
Well, typically you need to bring it right to the face or even a little bit through. Many times inspectors actually want to see that grid sticking through the face of the wall a little bit to prove that you actually put it in.
What do I do with these unsightly little tabs? That a homeowner's...
Some guys burn them off.
All right, fair enough.
But no, if it's just your residential project, pull it back slightly from the edge, but you don't want to be doing this. That's not the right way to install grid where you're completely behind the wall.
Okay.
That's going to help stabilize the aggregate a little bit, but it's not going to tie everything together.
Gotcha.
So no glue needed. Those pins go right through. It folds into the batters or the tongue and groove locking system of different wall blocks. If you have the spacer clips, they push the grid down and lock that grid in place. But otherwise, it's just friction that holds it, right?
All right.
So we're going to put this wall block on. And as you build up, as you get higher and higher and higher, the weight of the wall block, the weight of the aggregate compacted behind it, just starts to lock the entire structure together.
Very cool. And then if I have any of this stuff excess hanging out, I can burn it off or cut it off just to be
cut
sure
it
it's-
off, burn
All
off
right.
the little ends.
Great. Time for questions. What questions have we got coming through?
All right, we can't see anything up there.
Are you suggesting that we use grid in most base prep, whether it's a patio or a wall?
I certainly would. I would promote the use of grid in any kind of aggregate base. You can reduce the thickness of the required base by putting that grid in there. So raised patios, definitely. If you want to do it as a matter of course in your regular patios on grade, on driveways, it's really going to work well.
In essence, there's no possible negative consequence by adding grid.
There's no possible negative consequence. It's completely free draining. You can see the size of those apertures in there. It's going to provide great reinforcement, and you can even reduce the amount of base, and you'll get better performance.
Very cool. Another question? Should you place grid on a compacted layer or leave it rough to help migrate into the apertures? Someone got caught with the word. And they
Yeah.
spelled it correctly.
That's pretty fancy,
That is
right?
pretty fancy. That's good.
All right, so you never want to run your compactor directly over grid
Why is that?
because it could damage it.
Okay.
Right? We don't want to damage this stuff. It's pretty tough. I mean, I can't pull it apart, but stone can be sharp. especially if it's shale or something, and that can potentially, cause some issues if you have unyielding object to unyielding object. We account for a certain amount of damage. We've tested these products and dug them back up and tried them after they've been pulled out of the ground and made sure that they still retain enough of their strength.
Cool.
My recommendation would be to install your grid here, right? We've compacted this stone, for example.
Yep.
We install our grid. We put stone down on top of it, 4 inches, whatever we're doing, 6 inches. Compact, whatever lifts are appropriate for the size compaction equipment we're using.
Yep.
Lay down another layer of grid, more stone, compact. So you're not going to be bothered. It's not going to affect the integrity of your job by compacting that previous layer.
Gotcha. One more question. Do you have a specification on how much we can reduce base stone by? That's a great question, because you just touched on that here. By adding the grid, I can decrease the amount of stone needed. Is there a formula for that?
There is no easy formula or easy answer for that question, because it depends on so many different factors, not only the strength of the grid that you're using, but the actual aggregate that you're using. Gotcha. And the soil conditions. So the aggregate you're using, it could be modified, crushed stone, 3/4 with fines in it. It could be clean stone.
Right.
It could be crushed concrete. There's all kinds of different base materials, and they all work a little bit differently.
Okay.
I would be comfortable, as a rule of thumb, by reducing 25% in a typical installation, putting a layer of grid
Call it the
into
rule
the
of Jack.
base material there. Yep.
The rule of Jack. One more question. How would the grid work with Gator base?
Well, the grid's not going to really give you much benefit with Gator base, right? Gator base itself is giving you that load distribution.
Yep.
It's got drainage built into it. It has that snowshoe effect, spreading that load out over a larger area.
Plus, by having Gator base, you're eliminating the need for this
We
anyways.
don't have any crushed stone underneath Gator base. That's a good point, Topher.
Yep.
So it doesn't serve much purpose. It's not going to hurt anything, like we talked about before, but you're not going to see a ton of benefit to the application of grid in a Gator-based project.
Perhaps a belt and suspenders sort of approach.
Yep.
A little bit of overkill. All right, what do we got next?
Well, I think that pretty much wraps up grid here. So grid's really important, right?
Okay.
I don't think we can stress that enough. Fabrics are very important, but typically your failures by skipping grid are a little more dramatic than your failures from not using fabric.
All right. Is this where we go to that really cool video?
Well, we're going to show you some dramatic failures, right? We're going to show you a little bit about our fabrics, and we went to some extreme lengths to test these the other day.
All right.
We want to prove a point, and it may not be the point that you think from seeing the video, so let's roll that.
All right, hey everybody, this is Lions Gator team, George, Topher, Mike, you're gonna see in a minute here. It's a cold, snowy February day in New Jersey, and we're here to test the differences of our spun bond, our non-woven and our woven fabric. So up on the lift, we have Mike Huber. He has, what do you got in your hands, Mike?
Well, I finished a permeable job a little while ago. I've got 25 pounds of leftover aqua rock, so I thought I'd toss it onto some of our fabric from 25 feet up and see what happens.
All right, we got 25-pound medicine ball, and it's gonna come from 25 feet.
All right, we're dropping it on our GF, what is this? Oh, this is our spun bond, right? SB3?
This would be our spun bond.
All right, here
Topher,
it
what's
goes.
gonna happen?
3, 2, 1.
Wow, destroyed.
Yeah. Yeah, snapped it right in half.
All right, we'll be back with another test.
All right, next up we have our GF 4.4 non-woven fabric. We blew apart that spun bond. What do you think will happen here?
I'm not sure, man. This looks a little stronger.
I'm
Yeah,
going for a
it's a little
bounce. Going for a bounce.
Here it goes. 3, 2, 1.
Yeah! Bounce!
Oh, look, it looks like it dented it pretty good.
Good dent, but a little stronger than the spun bond.
Is that a rip in the bottom?
We do have a little tear, but given that you're dropping 25 pounds from 25 feet, makes sense.
Yeah.
All right.
Definitely stronger than that spun bond.
All right, Mike. We have our GF5 here. This stuff is like a blue tarp. It looks super strong.
It is pretty tough stuff. Let's see how it holds up to 25 pounds from 25 feet, though.
Give it a shot.
All right, here it goes.
if I'm going to use fabric, I'm going with that. It's obviously the strongest. All right. A, that was freezing. B, that was pretty cool.
Aren't you from Maine?
Yeah, but I've been living down south for a wicked long time, so my blood has definitely thinned.
Yeah, well, welcome to winter in New Jersey.
Yeah.
All right, so that was pretty cool.
Yeah.
We had some fun with that, and that GF5 seems to be the ticket, right?
Absolutely. If strength matters, why would I not be going with that product?
Well, strength isn't the only thing that matters. In fact, I would argue that drainage is more important than strength for most of our hardscape projects.
Interesting. Okay.
Yep, and we're going to touch on that as we do these little demo tanks. What causes failures in a hardscape project?
Water.
Water. It can cause efflorescence. It can cause polymeric sand to fail. It lubricates the base and allows all those particles to start moving and migrating.
Yep.
What happens in freeze-thaw cycles?
Heaving.
Right,
Lots of heaving.
so heaving. Everything moves if you have water in a system.
Yep.
So we don't want water in our system. And I think that GF5 might have a little problem with retaining water and preventing drainage.
But it's so strong.
Well, you can't have everything, right?
I got such a big bounce out of the aqua rock.
All right, so before we actually do this last demonstration, we're going to talk about all of our fabrics briefly.
Okay.
First one is the polyspun. So this is our GF20. And the GF20 fabric is really meant to be a weed barrier fabric. It's a landscape fabric.
All right.
Right, it's kind of flimsy, right?
Yep. Not much to it.
Yeah. Not much to it, but it serves its purpose, right? It's going to provide separation between your soils and your landscaping stone, your mulch bed. It'll help prevent weeds. Weeds grow from the top, though, so eventually you'll get them. It's not going to prevent them forever, but this is a great landscape fabric. 20-year lifespan. It's specially treated to be hydrophilic.
All right, you lost me. Hydrophilic.
Hydrophilic, water-loving. So it's actually going to suck that water down through faster than any other fabric out there.
All right, okay.
Which is a pretty cool feature. So 20-year lifespan, hydrophilic, sucks that water down. That's good for plants, right? You're using landscape beds. We want that water to get down to the roots and everything.
And not as concerned as far as strength and integrity as far as being able to throw something and puncture it.
Well, it's got pretty good puncture resistance, so your stone aren't going to go through it if you
Right.
walk on top of them or anything like that. But yes, it's not super strong. It's not meant to be used underneath hardscape projects for sure.
All right. So I'm not putting this under a driveway.
You're not putting it underneath a walkway, I hope. All right, next up is our spun bond material. So you can see this material here. It's definitely more substantial than the GF20.
Now, was this the first one that we threw stuff through outside in that video?
Yes.
Fair enough, okay.
So it did burst, right? It did tear, but it is definitely stronger than that polyspun material.
Right.
Spun bond comes in a couple different weights and strengths, but that video proved you probably shouldn't be using it underneath your hardscape project, right? This is still more of that weed barrier type fabric. You know, it's a stronger weed barrier type fabric than the polyspun, but it's still not strong enough to work as that reinforcement layer underneath a hardscape project.
Okay.
Unfortunately, we do see it used in that fashion quite a bit.
Of course we do. And when asked why do we use it, 9 times out of 10 the answer is, I don't know. We always have. That's why we've used it.
Right. So hopefully you walk away from our presentation today with a little more knowledge on what you should use.
And to reinforce the thing, we're giving a lot of information here. When in doubt, reach out to your local rep throughout the country. We've got over 30 reps throughout the United States. Be sure to reach out to us and use us as a resource. I think we've got a question up here. If you use grid, would you not use soil stabilizer fabric?
Well, you'd probably always want to use your soil stabilizer fabric. That's going to give you that separation between your native soils and your aggregate. That grid should be going in the middle of your aggregate base. So it shouldn't be going directly at the bottom. You're going to get the best, bang for your buck, the best reinforcement if it's right in the middle of your aggregate base.
Because grid really isn't going to prevent any type of migration to that native soil, depending upon the size of your aggregate.
Exactly. It's certainly not going to eliminate it completely the way a fabric would.
Gotcha. All right. And then what do we have? Oh, sorry, one more question. Does grid affect any wall with a built-in locking system?
I haven't encountered any yet that it won't work with. Grid's an important part of building a wall, right? So when manufacturers develop a wall system, they make sure that it works with grid. That's kind of the idea. One piece works with the other piece. So as far as I know, grid can be used with really any wall out there.
Fair enough. And what do we got here? This is my favorite. This is one I picked.
We're not ready to go there yet.
We're not?
We still
Oh,
got to go
okay.
to the middle here.
Okay.
Right? So this is our non-woven fabric. Now this stuff's tough. You know,
Yep.
This stuff's kind of like a really heavy-duty felt.
It held up pretty well. It was pretty impressive. Got a bounce. Still got punctured, though.
Yeah, it still tore a little bit,
Yep.
but I would personally suggest that this is going to be the ideal fabric for your residential hardscape projects. It has the strength that you need. It has enough strength, and it also has great drainage, which we'll show you in a minute.
Okay.
That drainage is so important, and if a 2x4 is going to hold up the house, why do you need a 4x4?
Fair enough.
Right? All right, so very great drainage, pretty reasonable strength. I
Yep.
mean, it held up pretty well to our test outside, our stress test. It's a great all-around fabric. Now on to your favorite.
This is my favorite. What have we got here?
That is our non-woven GF5. Now that's some incredibly tough stuff.
Now, putting my hands on this and feeling it, I'm reminded of the blue tarp that's covering my wood pile in the backyard.
I think it's tougher than a blue tarp.
I think it probably is as
A
well.
blue tarp you could probably tear by hand if you
Yep.
wanted to, but this stuff's pretty strong.
Yep.
Hard to rip, hard to puncture. It's really, really strong, but it just does not drain.
Prove it.
All right, let's prove it. We've got about a gallon and a half, 2 gallons of water here, and I'm going to pour it into the GF5. So you'll see how slowly that's working its way through.
That's a lot of water.
It is a lot of water.
It's retaining a lot of water on the top, and
Yep.
especially in this cold weather, that's going to turn into an ice puck.
Yep, it's not moving through there all that well. We still got water in there.
In fact, it's slowing down.
Slowing down. We would have hoped it'd speed up. Uh-oh. We might never get to the end. Let's move on.
Yep.
Let's try that GF 4.4 here, right in the middle. So that's going through almost as fast as I can pour it. And our GF5 is still draining.
Still and still slowing down.
All right. Now what do we got? We got our spun
Spun
bond
bond.
material here. So I'm going to pour this through. That one flows pretty well too.
And again, the biggest challenge with most hardscape projects,
Is water. All right, so our GF5, Topher's favorite, is still a puddle of water.
So strength isn't always the best thing that we're looking for.
Right, that's fantastic, the GF5 for areas that have clay soil,
Yep,
right?
okay.
If you've got clay soil that's weak, subject to deformation, that won't drain anyway because it's clay soil, then why not use a GF5 to get the most strength you can out of it? In any other soil type, you'd want to use this 4.4 for a residential patio, walkway, even most residential driveways. I would suggest the GF 4.4 because that drainage is going to get that water out of there.
Okay.
And if you get that water out, you're going to eliminate so many potential problems with your hardscape project.
We're still draining.
Spun bond, drained well,
Yep.
but it kind of blew apart in our test there.
Little less structural
Doesn't have
integrity.
that strength to really provide reinforcement on a hardscape project. So spun bond, poly spun are great weed barrier
Yep.
fabrics. GF 4.4, great all-around hardscape material. I mean, you could certainly use it for weed barrier. A little expensive.
Yep.
Works great for underneath all your hardscape projects for separation, reinforcement, and drainage. And, oh man,
We still have water.
there's still a puddle of water in there.
We got some questions coming through. Should swap out my blue tarps with this. Putting two 20-foot containers on the ground, use Gator board or grid.
Well, that's a unique one. I guess they're putting some shipping containers in and they want to reinforce the base.
I'm assuming Gator board is Gator base.
All right, well, I would certainly recommend Gator grid and some aggregate.
Yes.
So maybe do, 4-6 inches of aggregate with a layer of Gator grid in
And
the
a lot
middle.
of variables in that question. Where's that displacement of weight? What's going in those containers? How many points of contact on the ground? Lots of variables in that question there. What else we got? Would it be best to use the GF5 in a permeable project?
Well, that's a good question,
Very
right?
good.
We just showed that it's not permeable.
Yep.
But I think there are some reasons why you might use GF5 in a permeable project.
You'd want to go and wrap it up and keep everything separated out?
Right. Typically, you're building a reservoir in a permeable project. So you would normally want that to capture all of the water that falls and slowly leach it into the soil.
Okay.
So in that case, you'd want to use the GF 4.4, that non-woven fabric, allow that to capture all the water and let it soak down into the soil. However, There are some permeable systems that are designed as a capture and exfiltrate.
Right.
So you build that reservoir, you capture all of the water, and then you send that water somewhere else to a retention pond, a drainage ditch, something along those lines. Right. So if you're going to capture all of your water anyway,
and then migrate it out,
or use it for irrigation, then the GF5 is your ideal fabric.
Just 'cause it's
if you want that water to go back into the ground, into the aquifer, underneath your project, you better go with the non-woven 4.4.
What else we got for questions? The weight of base will make it drain better. No?
Certainly. Contact, wet, the fabrics being wet, we pre-wet all of these so that they did drain a little bit better. And having them in contact with the soil, with the aggregate, will help them drain a little bit better. But we're not talking 100% better, 200% better. We're talking marginally better.
Right.
But there will be more water flow. That's a good point. We still have a puddle here in our GF5, though.
We do. We do have a puddle. Another question? With poor drainage soils, does it matter whether you use a 5 or a 4.4?
It really doesn't. If you have poor draining soils that aren't going to allow water through them anyway, then GF5 is probably the best bet because it's going to give you more strength over those poor draining soils, which are typically substandard for bearing strength.
Right.
So let's use that strongest fabric that we have, greatest improvement to that structural integrity, and we'll account for the drainage some other way, whether that's a drain pipe to a dry well or daylight. We need to get water out of a project, but through the fabric and down through the bottom isn't the only way.
Yep, fair enough. I think we're done with questions. What else we got?
Well, we are pretty much wrapped up here. Hopefully we gave everybody a pretty good run through of fabrics and grids. It's a pretty dry subject, right?
It was.
You can, bore yourself to death reading all the specifications on these things and how much they weigh per square yard.
And if you registered, you will get this recording so you can bore yourself to death again.
But it really does make a huge difference in the overall integrity, performance, and lifespan of your hardscape project. You're talking about pennies per square foot. I don't sell this stuff, but he does. And it's pennies, right?
It's pennies.
Yeah, pennies per square foot. So for pennies per square foot, when you're spending $3, $4, $5 a square foot on pavers these days, it just makes sense to me.
Yep. Thank you guys for attending. At the conclusion of this, you will have an opportunity to register for for those gifts that we talked about before. You're also going to have access to our education portal, where we're going to have continued education throughout the coming weeks. This is our opportunity to get in front of you guys in a safe, socially distanced way. Thank you very much for your attention. Thank you very much for your business. Stay healthy, and we look forward to seeing you next week for next week's class.
Next week we're doing sealers, right?
My favorite. Now that I could have gotten excited about.
Yeah, sealers are definitely exciting. They're, a lot of people are afraid of sealers, but we're going to make it nice and easy for you. You don't have to be afraid of them. You can use them successfully, and I hope you tune in next week.
Awesome. Thank you very much.